on to the next group. These are the solutes. And remember, solute means free, so they're free to flop around. Kind of like all the other things we've talked about. We haven't got to anything that's rooted yet, but these got their name from that concept, and so, okay, fine. The solutes have the one little arm for feeding at the top of the head. Yeah, just like that. That's the most common type you get. And this thing, boy, does that look like a stylophore. Yeah, wow, does that resemble a stylophore. But the way the plates are put together, it doesn't quite meet our definition of a stylophore. Now, does it meet an Echinoderms definition? I don't know. Did it come from the same genes with some slight modification? Maybe. But there is a chance that this is convergent evolution, that this is something more like a crinoid stalk that has maybe become something more stylophore-like in function. So currently not considered to be a stylophore. They do have little cover plates, and they have cover plates that I believe run up the arm. So we think these are ambulacra. So these are little tube feet that are hidden under a little cover plate that can open, and then the tube feet can come out and suction cup, stick to things, and so the mouth would be somewhere very near this, maybe right at the base of this, and the tube feet would act like a little assembly line. They just sort of grab food and pass it down until it goes to the mouth. So one grabs it, gives it to the other, grabs it, gives it to the other, just like that. Yeah. All right. Anus is at the bottom, mouth is at the top, so they probably have like a pass-through gut, but it may snake around on the inside. We don't, as far as I'm aware, have good soft body preservation of these yet, although something may have been published that I missed. Yeah. So those are solutes. Yeah, with the one little arm on the top, but looking kind of like Stylophorans, I think. Yeah. Except for that feeding arm. Yeah, which is fully articulated. It's not just a big plate like in Mitrates. You got just a big plate there. All right. Next group of weirdos. These are the Edrioasteroids. And so Edrio is like fixed, stuck to something. And look at them. So it looks like on the top surface, it looks like a starfish. And these are all plates, little cover plates for ambulacra, we think. The ambulacra, of course, are going to be soft parts. The little tube feet dissolve immediately after these things die. So you don't usually, I don't think you ever recover those in a fossil. But you can get the plates, and from the arrangement of them, that's kind of the only thing that makes sense. So imagine these little plates opening up so it can stick its tube feet out, and these things are just fixed to one spot. So this one, it's not a stem of the Edrioasteroid, it's the Edrioasteroid on a crinoid stem. So they just stick to something that's hard, or they stick to semi-hard, just seafloor, and they grow there in place. No evidence that they ever moved. They just probably got bigger in place. The mouth is going to be almost certainly at the center because these arms are there to provide food for the mouth, and so they'll just be funneling stuff in. And then the anus is located down here. There's usually two arms that curl in like that, and the anus is usually located between them. So the anus is toward the bottom in all of these, at least where it is known. And so usually, yeah, two arms kind of hugging its anus. Isn't that nice? Yeah. This is a very weird one. It's an Edrioasteroid that's stretched out really tall, which is something that the early versions of things like Edrioasteroids used to be more like that, more like figure G. Yeah. So here is one of those. I think it's currently listed as being in its own class or something like that, but people talk about it as if it is an Edrioasteroid or an Edrioasteroid ancestor, and I think that's probably the best way to understand it. So we'll pretend that Camptostroma is just a really early, kind of weird version of an Edrioasteroid, but it was puffy, so mostly inflated, and then when they died, they get squished absolutely flat, so it was possibly organs or soft tissue, but like soft tissue with a lot of air in it, like a digestive tract or something. Just a lot of space for food or something that would get just compressed down to nothing in fossilization. On the top, there's going to be a little 5-pointed star, which is hard to see here, but you get a couple of arms The mouth would be tucked in right about here, right about the center. We think there would have been a little anus in between two of the arms curling around. And if that doesn't look like an Edrioasteroid, what is it? But these things are mostly known from, I think it's southeastern Pennsylvania. And mostly they've kind of fallen apart after death. It is hard to get one that is really intact with everything in place. What people tend to find are upside down versions. And what they're looking at, this is the bottom. This is like the seam where it would have been stuck to the floor. It's like the, the suction cup at the bottom, basically. The side that would have the arms on it tends to get disarrayed in the particular formation, which is the only place where these things are commonly found. So it's just a case of if they were fossilized somewhere else, we might have a better idea of what they are, or we might have no idea because they might not have fossilized at all. So I guess be grateful for what you get with fossils. Yeah. Okay, so those are Edrioasteroids. This is a different group, but darned if they don't look very similar. So Cyclocystoids, the main way you recognize these is they're going to have a ring of little plates. Go right around the outside. Sometimes these little plates are going to have two little holes, like little balconies or little nests in them. And those actually go through to the inside. So something like a tube foot could have stuck out through the edge of these little holes. In the center, they probably had ambulacra. The little plates tend to get kind of mixed around. And there are these ring-shaped plates, little annular plates, and we don't really understand what's going on there. Was there some kind of tube foot or tentacle that was tasked with passing food to the mouth? These are fairly flat, like most Edrioasteroids, and usually it's only the ring of plates that you find. And so we do have some of these, and you can have a look at them. And it just looks like a ring of plates from the outside and little bits of a suggestion of what might be going on in the center. But this is actually a much better specimen. You can see the nice little radial plates, which are probably the mouth. They seem to be pretty central. It is also possible that that's the anus and the mouth is somewhere else we haven't quite figured out yet. Because remember, the mouths and the tube feet may be under little plates that close and open. And so you may not be able to, it may not look like an open hole on there. The flap may be shut. Yeah. And the mouths are not always symmetrical. This one's, whatever that is, it's nice and five-fold symmetrical. But if you look back at, like this one, look, that's the mouth, this sort of zigzag shape. And I guess it's tough to see. There's the nice one. Yeah, see that sort of zigzag shape? That is where the mouth is, somewhere at the center of that. So, yeah, pretty weird. Pretty strange. Okay, we'll do a couple more of these we're getting into these are things that are rooted to the ground and are starting to look a little more like a balloon. And that's going to be the direction that several of our other groups are going to take. So these next two, we'll just show them on the same slide. They're probably related to each other, but if you look at their plates, they're not really closely related to each other. So you've got Helicoplacus, which has these ambulacra. That's this sort of Y-shaped 1, 2, 3. This one's going to wrap all the way around the back. So that's this end one. And then splits here, and this one's going to wrap around to there. And this one's going to wrap all the way around right up here at the top. So it's like somebody took an Edrioasteroid and twisted it like that. Yeah, weird, super weird. Twisted it and stretched it out really tall. Yeah. Strange. Helicoplacoids. People who work in echinoderm evolution are very cautious about where to put these things, because if you say that the shape of it is important, then they end up out on their own. If you say that the number of ambulacra, which is 3, are important, then they end up in between other things that are clearly a group on their own, and then this thing doesn't look like it belongs. We don't have any good idea of the soft tissue on these. We do have an idea of where the anal plates are. There's a fellow working out of Texas, James Sprinkle, I think is his name, and he's fantastically good at echinoderms. I think retired now. Here we've got Helicocystis, and it's like a little tiny crinoid cup, or almost like an eocrinoid cup. We think rooted to the ground, but then with something that is twisted. But instead of having 3 ambulacral grooves, it looks like it has 5 with kind of 5-fold symmetry, just twisted around with an anus that happens to be on one side. So again, kind of like an Edrioasteroid, but twisted, but an Edrioasteroid with 5 little arms attached to the cup instead of one with 3. Yeah. But we will see later that 5 and 3 are not so different as you might think. Because if you have 3 and you just split that one, and you split that one, then all of a sudden you got 5. And that's actually how they do it. And we've got good evidence for that. So that's enough of these guys. And then we'll go on to the things that are getting closer toward crinoids and modern echinoderms in the next section.